you also have the PDF defined on this one, and this will give you this integral. Okay, this is integration of course g of x into dx. That's what it will give. Okay, so what you have to find is actually if for a given y you are interested in finding the density function of y. If it is depending, it may be a monotonous increasing decreasing function, or it may have multi values. Find out all such values of x that will give rise to the value y through this function g of x. So there may be many values x1, x2 and so on. All of them you plug in, you will get the value of y. So the fy of y is related to fx of x at x1, x2 and so on, where x1, x2 are such that on plugging x1, x2 in g of x you get y, the same y. We know that relationship, but again you have to multiply it by, for the sake of normalization, you have to multiply it by normalization constant, and that is what, how they are related is, if there is a monotonous function, there is only one value that corresponds to fy of y dy should be equal to fx of x dx. So if you want fy of y, that is equal to fx at x. Which value of x? It is the g inverse of x, g inverse of y. So this is a specific value. There is an x such that g of x is equal to y. So that x is actually g inverse of y. At that value we evaluate f of x into dx is that, dy is that, this is dx by dy. But again, the function y may be increasing, decreasing and so on. So dy by dx and also dx by dy may be negative or positive, but this should always be positive. So you put a condition that it has to be positive. It is only a transformation. Okay. For example, what will happen is you may have a case where theta, that is between minus pi by 2 to plus pi by 2, right? And then it is uniform, let us say theta is uniform between minus pi by 2 to plus pi by 2. And you have a function tan theta. Okay? If I am right, it will be of this form, right? So what will happen is, theta is confined over a very small region of pi, that is the region. But if you look at tan theta is ranges from minus infinity to plus infinity. So if you look at a small strip of width d theta, then f theta of theta d theta will give you the probability that theta is confined between theta to theta plus d theta. Correspondingly, if you look at the value of y which is equal to tan theta, it will be here. So that will be y and y plus dy. Those properties are equal. But what will happen is, if you go near this one, even for a small angle, actually I should this one, even for a small angle, there will be extremely large values of y will get mapped onto. So the probability density function is being stretched or compressed because the range of the independent variable and the range of the dependent variable are different. That is why we are multiplying this factor. You have to be very, very clear about that one. Why we are multiplying this? Although we are able to equate, okay, which x and which y are related. So the density at this point is also equal to the density at that point, but the density function itself is being stretched or compressed, and because of that this factor is being introduced. That is called as the, in general called as the Jacobian of transformation. Let's now look at a case of two variables, x, y are two random variables. Then we have u and v are functions of x and y. Using two ordinary functions g of x comma y and h of x comma y. See, these are just two ordinary functions. Okay, so as we know, as we deal with calculus and so on, just function. But now what we are doing is these random variables are related to the random variables x and y through these functions. By that what we mean, u is equal to g of x comma y and v is equal to h of x comma y. So suppose we are given the joint CDF and the joint density function PDF of x and y here, it's being given to us. Now we are interested in finding what are the joint CDF and joint PDF of u and v is what we are interested in. So that is, if you in simple form, I try to use this notation to avoid confusion. So this is what we are looking at. How do we find it out? Well, so u is given by g of x comma y, h is given by this one. So f uv of u comma v is nothing but the probability that u is less than or equal to u, v is less than or equal to v. This condition has to be obeyed. So, if we can find a region in, of course, this condition in the u and v plane, uv plane, correspond to a region in the x1 y plane. Because all points in that region in x1 y plane will map onto points u comma v such that these two conditions are obeyed. The probability of that region being, okay, the probability of occupancy of that region in xy is the same as this. So which means that you can just integrate over fxy of x comma y dx dy, wherein this condition is obeyed over the entire domain, but subjected to this condition. What is this condition? U is what? G of x comma y is less than or equal to u, and h of x comma